Are you really aware of the violence that reigns in the universe? From Earth, the celestial vault seems calm, peaceful, and unchanging. This was also the view of the first astronomers, who sought to understand the sky and its captivatingly bright objects. Beyond the image we have of it from our planet, the universe is in reality the scene of events of rare violence. Collisions of galaxies, supernovas, asteroid and comet impacts. The universe is subject to phenomena that keep it constantly evolving. Thanks to some of these events, the Earth has been able to evolve until it became conducive to the appearance of life and mankind. Exceptional scientific advances in the field of astronomy allow us to understand and even observe firsthand this violence above our heads. Dear traveler, welcome. Today we're off to meet some of the most violent events in the universe. But before you set off on your next adventure, remember to like the video and subscribe to the channel so you don't miss a thing. Thank you, and have a great trip. The collision of two galaxies is an ordinary phenomenon in the evolution of galaxies. It occurs when two galaxies collide at sufficient speed to merge. The gas and dust of the two galaxies will then interact. The interstellar medium is disturbed and heated. This shock can trigger a starburst, also known as a starburst galaxy, in one of the two galaxies. This phenomenon generates an exceptional rate of star formation in one of the galaxies. These bursts are temporary, because if the rate of star formation were to remain so high, the reservoirs of star-forming gas would be completely dissipated much faster than the dynamic lifetime of the galaxy. The stars in the two galaxies, meanwhile, generally don't collide with each other, as the distances between stars. A starburst is generally defined by three factors: the star formation rate, which is the rate at which the galaxy will convert gas into stars, the amount of gas available to form stars, and the comparison between the star formation period and the age of the galaxy. For a starburst to occur, a large quantity of molecular gas must be concentrated in a small volume. This usually occurs during galaxy mergers. Categorizing the various starbursts is not straightforward, as not all galaxies share the same specific characteristics. Starbursts can occur in the galactic disk or be scattered throughout the galaxy. Nevertheless, astronomers are currently discussing a number of classes. The subtypes of starbursts currently defined are blue compact galaxies, infrared luminous galaxies, and Wolf-Rayet galaxies. Compact blue galaxies have low mass and low metallicity. Dust-free, they contain a large number of relatively young hot stars. As a result, they are luminous in the blue and ultraviolet. Astronomers initially thought these galaxies were young, but old stellar populations have been found in a number of them. In addition, the majority of compact blue galaxies show evidence of recent interactions. Infrared luminous galaxies are characterized by extremely high dust concentrations. They emit a red color because the ultraviolet radiation they emit is absorbed by dust and re-emitted as infrared. Most of the infrared luminous galaxies observed show a double core system. This suggests that star formation may have been triggered by galaxy mergers. In Wolf-Rayet galaxies, the majority of bright stars are Wolf-Rayet stars. These hot stars, with masses equivalent to several tens of solar masses, will start expelling matter in the form of high-speed stellar winds during a brief phase. A starburst has a large gas reserve. Collision with another galaxy triggers the starburst itself. Inside the starburst, the environment is extreme. Massive star formation generates large quantities of gas. One of the most famous starburst systems is the Andromeda Galaxy. The Raven constellation is one of the 48 constellations listed by the astronomer Ptolemy. It lies close to the constellation Virgo to the north and east, Hydra to the south, and Cup to the west. The Raven constellation has few bright stars. Its 4 brightest stars are Gamma, Beta, Delta, and Epsilon. Gamma, with a magnitude of 2.59, remains the brightest. These 4 are easy to spot in the night sky, as they form an unusual quadrilateral. However, the most striking celestial objects in this constellation are not these stars, but 2 galaxies that are currently on a collision course, the Andromeda Galaxies. Also known as NGC 4038 and NGC 4039, the Andromeda Galaxies are an emblematic example of galactic collision. While pairs of interacting galaxies are quite common in the universe, it's rarer to witness the spectacle offered by NGC 4038 and NGC 4039. According to scientists, the collision began 600 million years ago. The Andromeda Galaxies were originally 2 spiral galaxies. NGC 4038 is very large and lies at a Hubble distance of around 95.2 million light-years. It is also defined as a star-forming galaxy. It has an exceptional rate of star formation compared with other observed galaxies. This phenomenon represents just one stage in the life of a galaxy, and is certainly due to the interaction with NGC 4039. The phenomenon is therefore limited in time. The interaction of the Andromeda Galaxies in the night sky is a veritable firework display, illuminating thousands of nebulae and young star clusters. It's a spectacle of unspeakable beauty. The arms of the galaxies were deformed and the cores brought close together. The impact sent out 2 immense jets of stars and gas, earning this celestial duo the nickname the Antennae. With a 100mm aperture, it's possible to observe the galaxy duo, which appears as a diffuse spot with no detail. When viewed through a 200mm telescope, the dual nature of the object becomes clear. Its shape takes on the appearance of a V elongated towards the west. But it's only when you use 300 to 400mm instruments that the spectacle becomes striking. The 2 Andromeda Galaxies form a magnificent, asymmetrical boomerang. NGC 4038 to the north represents the brighter, more curved part, while NGC 4039 to the south is thinner. Astronomers believe that within 400 million years these 2 galaxies will have merged. For us, this gigantic timescale is nothing compared to the lifetimes of these stars. This collision could give rise to a larger galaxy, perhaps of the elliptical type. The nearest ultra-bright infrared galaxy is ARP 220. It is located around 245 million light-years from the Milky Way, in the constellation of Serpent. ARP 220 is the result of the collision of 2 galaxies that are currently merging into one. ARP-220 radiates mainly in the infrared. Most of its luminosity comes from the intensive formation of young stars, since it is a star-forming galaxy. Scientists have observed over 200 stellar clusters at the heart of this galaxy, some reaching masses of the order of 10 million solar masses. ARP-220 has an active galaxy core. This core is characterized by a compact region at the heart of the galaxy. Its luminosity is higher than average and not of stellar origin. In theory, it results from accretion by a supermassive black hole. The Whale constellation is the fourth largest constellation in the sky. Its best-known stars are Mira and Difta. Within this constellation lies the ARP-147 system, also known as the Ring Train. This pair of colliding galaxies lies 440 million light-years from Earth. The Ring Train perfectly represents the most spectacular effects of galaxy collisions. The two galaxies making up the pair are considered special galaxies in that they are neither elliptical, spiral, barred spiral, nor lenticular. They are, however, regular in shape. The two galaxies are shown, one in profile, evoking the number 1, and the other from the front, appearing to represent the number 0. Together they form a gigantic 10. This extraordinary figure in the sky is the result of an extremely violent collision. The galaxy on the left, representing the number 1, has smashed right through the galaxy on the right, representing the number 0. In the same way that a pebble emits a wave when it comes into contact with water, the collision created a wave at the point of impact. This density wave traveled outwards through the affected galaxy, colliding with the star's gas and dust as they tumbled towards the center, under the effect of an increased gravitational force. As a result of the collision, the high-temperature matter clumped together, stimulating the formation of young stars. A red spot can be seen at the bottom of the right-hand galaxy forming 0. This is probably the remnant of the galaxy's nucleus after the collision. Made up of around 50 individuals, the local group is a very modest cluster in which our galaxy, the Milky Way, lies. Nevertheless, its evolution has been as tumultuous as that of larger galaxy groupings. Based on the stigmata found on the Andromeda Galaxy, also known as M31, numerical simulations have attempted to reconstruct its past. At present, M31 is the only galaxy in the local group larger than the Milky Way. 5 billion years after the Big Bang, the local group is made up, in addition to the future Milky Way, of two rather large galaxies, one of which is 4 times more massive than the other. Their relative proximity generates a mutual attraction that brings them closer together, until they inevitably collide 4 billion years later. The merging of these two galaxies gives rise to the Andromeda Galaxy. The distances between the stars of the two galaxies are so great that another head-on collision is ruled out. Tidal forces create a gigantic trail of stars. Part of it returns towards the larger galaxy, the result of the ongoing merger, while the other part escapes the latter's grasp and gathers into two dwarf galaxies known as the Magellanic Clouds. Their speed is such that they soon find themselves close to the Milky Way. Supernovas are spectacular events marking the end of the evolution of a massive star. During these gigantic explosions, the energy released in a few seconds is comparable to that emitted by a star throughout its lifetime. The phenomena triggering these explosions vary according to whether the star belongs to a binary system or to a single star. In the latter case, a supernova explosion will only occur if the binary system's companion star is a white dwarf. Under certain conditions, the white dwarf is gravitationally bound to its companion star, absorbing matter from the latter's surface layers. The captured material falls onto the white dwarf and heats up. When it exceeds the mass limit at which a nova is formed, nuclear reactions are set in motion until it is destroyed. In the case of an isolated star, the star itself explodes once all internal nuclear fusion cycles have taken place. Gravity then takes over, and the star contracts very rapidly. The resulting heating triggers uncontrolled nuclear reactions in the core. An explosion occurs, releasing enough energy to destroy the star. The explosion leaves behind a trace called supernova remnant. This is an expanding cloud of gas. Astronomers identify supernovas by their characteristic light curve. They exhibit a rapid increase in luminosity that lasts several days. When this luminosity reaches a maximum, it stabilizes for around 10 days. It then decreases discontinuously, followed by a steady decline. Interpretation of the light curve enables us to study the evolution and dynamics of the explosion. Because of their extreme brilliance, supernovae are one of the favorite objects of astronomy enthusiasts. And it's thanks to them that around 50 supernovas have been discovered every year since 1990. Several supernovas have left their mark on the history of astronomy. On February 24, 1987, Canadian-born astronomer Ian Shelton set out to take long-pause photographs of the Large Magellanic Cloud, a dwarf galaxy close to the Milky Way, visible from the southern hemisphere. While developing his photographs, he was surprised by the presence of a new star. After consulting several colleagues, he discovered that the star had also been seen by others. The first traces of the explosion to reach Earth were carried by neutrinos, which are difficult to detect particles emitted rapidly, in very large numbers, shortly before the star's increase in luminosity. SN 1987A was the first supernova explosion of the 20th century to be observed by the naked eye under optimal observing conditions. It provided crucial data for understanding the mechanisms of these stellar explosions. The general principles governing the supernova phenomenon have been confirmed. Studies clearly show that 99% of the energy emitted by supernovas is in the form of neutrinos. But for the first time in 1987, thanks to the supernova explosion, neutrino emission was observed instantaneously. When the star's core collapses under the effect of gravitation, electrons merge with protons to form neutrons and neutrinos. The latter interact very little with matter and are immediately released. Another feature of SN 1987A is that the star that gave rise to it was a blue supergiant. The presence of 3 gas rings around the supernova made it possible to understand that the star had evolved from a red supergiant to a blue supergiant around 20,000 years before the explosion. This progenitor star is called SK 69202, or Sandelique 69 degrees 202a. It was born 10 million years ago with a mass 20 times that of the Sun. Astronomers were surprised that it was a blue supergiant rather than a red one, as it was suggested at the time that only stars in the red supergiant stage evolved into supernovas. Today, the supernova afterglow remains the focus of numerous observations, even if the search for the compact residue has so far been unsuccessful. Thanks to numerous instruments on the ground and in space, the supernova has been observed continuously, both in terms of electromagnetic radiation and by neutrino detectors. The phenomenon occurred at a distance of around 51.4 kiloparsecs from our planet. In May 1987, it reached its maximum brightness, with an apparent magnitude of around +3. Supernova 1993J occurred in galaxy M81 in 1993. It was discovered by a Japanese amateur astronomer and was one of the brightest supernovas of the 20th century. Its ancestor has been identified as a K-type supergiant star, characterized by an excess of ultraviolet light, which may be due to the surrounding hot stars or a hot binary companion. SN 1572, also known as Tycho's supernova, is a supernova in the constellation Cassiopeia, 7,500 light-years from Earth. It owes its name to the Danish astronomer Tycho Brahe, who first observed it on November 11, 1572. On that day, it appeared much brighter than Venus, with an apparent magnitude of -4. It wasn't until March 1574 that its brightness dropped below the threshold of visibility to the naked eye. This supernova became one of the most famous events in the history of astronomy, since it contradicted the Aristotelian theory of the inalterability of the cosmic world. Indeed, since ancient times, the world beyond the moon had been considered unshakable. For scientists of the time, it was only between the Earth and the Moon that new celestial objects could appear. Tycho Brahe's discovery implied a new object much further away. Over the course of months of observation, he also discovered that the object had not changed position relative to the fixed stars, and could therefore not be a planet, but another star. In 1573, Tycho Brahe published his discovery, calling it a new star. This revolutionary expression turned astronomy on its head. It led to the development of better astronomical classification catalogs and improved observational instruments. The supernova's progenitor star was probably a dwarf that had drawn in matter from another companion star until it exploded. Type 1 supernovas, like SN 1572, do not involve the formation of extraordinary nebulae. That's why its faint afterglow was only discovered in the 1960s. Thanks to the Chandra Space Telescope, astronomers were provided with astonishing images of Tycho's supernova. These showed lumps in the remains of the star, as if several ignition points had existed within the supernova. The explanation is that SN 1572 underwent an asymmetric explosion. The explosion produced a large cloud of expanding debris. A thin blue line, representing ultra-high energy electrons, can be seen around the perimeter. The dust formed is ejected into the cosmos. Numerous other stars adorn the supernova's vicinity, like sparkling white diamonds. SN 1604, also known as the Kepler supernova, occurred in the Milky Way in the constellation of Ophiuchus in 1604. It is a type 1A supernova, or thermonuclear supernova, resulting from the explosion of a white dwarf. In most cases, the latter captures the matter of a companion star until it reaches critical mass and explodes. In the case of Kepler's supernova, however, it appears to have been triggered by the merging of two white dwarfs. As there are no bright stars in the vicinity of the central region of the supernova's remnants, SN 1604 was observed by German astronomer Johann Kepler and was visible to the naked eye for over a year. Kepler was not the discoverer of the supernova, but it was he who carried out the most detailed research on the star. He wrote about it in his book, Sur la nouvelle étoile dans la pied de Ophiuchus, On the New Star in the Foot of Ophiuchus. This supernova lies at a distance of 20,000 light-years from our planet Earth. Its relatively low position on the horizon and declination of minus 21 degrees could have made it difficult to detect, but certain circumstances were favorable to its discovery. SN 1604 lies in a region where the planets of the solar system circulate. In October of that year, Jupiter, Mars, and Saturn were located in this very zone. What's more, with the Sun at the same time located around 60 degrees west of this region, the sky was easily observable in the early hours of the night. What's more, Tycho Brahe's discovery some 30 years earlier had sparked a great deal of interest among astronomers in observing the night sky. Today, NASA astronomers report that some debris from the explosion is still moving through space at speeds of up to 37 million kilometers per hour. The average speed of the clusters studied is around 16 million kilometers per hour. The four fastest clusters in SN 1604 are all heading in the same direction and have a similar chemical composition. This may mean that the debris is coming from a single layer of the progenitor star. These velocities have already been observed in supernovae and other galaxies, but only just after their explosion. In the case of SN 1604, the displacement of its remnants continues unabated, even 400 years later. Astronomers have yet to explain this phenomenon, but several theories have been suggested. The explosion could have been so violent that the material was ejected at very high speed, or the white dwarf's environment is lumpy and the debris made its way along low-density paths without being slowed down. SN 1054, also known as a supernova of the year 1054, is famous for the afterglow it left behind after the explosion, known as the Crab Nebula. It is one of the most studied objects in the sky. The supernova was observed in 1054 and documented by Chinese and Arab astronomers. Numerous written sources attest to the explosion of a star in 1054. At the time, in China, transient stars such as comets, novas, or supernova explosions were called guest stars. Several accounts in official archives of events during certain dynasties relate this phenomenon in 1054. 3 other Japanese texts, individual chronicles, also mention this guest star at the same time. In the Arab world at the time, astronomers were interested in cyclical phenomena, whereas supernova explosions were considered to be atmospheric phenomena. Nevertheless, there is a doctor's account of a spectacular star appearing in the sky. All report that in July 1054, a star began to shine so brightly that it exceeded the brilliance of Venus. It remained visible in daylight for 3 weeks, and in the night sky for almost 2 years. 7 centuries later, in 1758, the famous Charles Messier searched assiduously for Halley's Comet and confused it with a small nebula in the Taurus constellation. To avoid further confusion, he decided to create a catalog of diffuse stars and assign the number 1 to this star. In 1928, Edwin Hubble made the connection between the Chinese astronomer's guest star and the Messier 1 nebula, the expanding cloud of gas released by the supernova of 1054. It's nicknamed the Crab Nebula. This nebula continues to grow at a speed of 1,500 kilometers per second, or 930 miles per hour, and will dilute in space over the coming millennia. Within the nebula remains the compact residue of the exploded star, the Crab pulsar. The pulsar is less than 1,000 years old. It generates electromagnetic radiation 100,000 times more intense than the Sun. This is what makes the central part of the Crab Nebula so bright. The nebula and pulsar form one of the most studied structures outside the solar system, as both are among the brightest objects in their respective categories. What's more, the date of the explosion is well known. SN 1054 is the most famous supernova in the history of astronomy. In winter in the northern hemisphere, it can be observed through a small telescope and appears as a pretty gray blob against the stellar background of the Milky Way. Supernova 2014J occurred in galaxy M82 in January 2014. It is a Type 1a supernova, and the closest to it discovered in over 40 years. To date, it remains the brightest supernova observed in the Cigar Galaxy for decades. It has been extensively studied in different wavelengths due to its unusual brightness and proximity. Far less spectacular than Type 2 supernovas, which are the endpoint of massive stars, whose remnant is usually a neutron star, Type 1a supernovas are produced by the explosion of much smaller stars, known as white dwarfs. Their explosions are said to be thermonuclear. At the end of the explosion, all that remains in space is a gigantic jet of particles known as afterglow. The supernova was discovered on January 21, 2014 by chance, while astronomer Steve Fosse was training his students to use a small telescope at the University of London Observatory. The scientists simply wanted to take advantage of a brief gap in London's cloud cover. He and his students then noticed a bright new star in the images taken of the Cigar Galaxy. The discovery was reported to the Astronomical Union's Central Astronomical Telegram Office, which confirmed that they were the first to spot this supernova. At the time of discovery, the supernova was 14 days from its maximum light, suggesting that it would become brighter over the following 2 weeks. It continued to get brighter until January 31st, when it had an apparent magnitude of 10.5. Quasars are the brightest sources of light in the universe. The word quasar comes from an English abbreviation meaning source of quasi-stellar radio radiation. These are extremely distant stars that look like very bright stars when observed through a telescope, but are actually examples of active galactic nuclei. Their impressive energy comes from the accretion of matter by rotating supermassive black holes that can contain millions to billions of solar masses. The black holes that sit at the center of galaxies are of an altogether different caliber to those produced by stars. While the latter sometimes reach the mass of the Sun, galactic black holes are millions, even billions of solar masses. The luminous power emitted by quasars can reach 10,000 times the total luminosity radiated by the hundreds of billions of stars in a galaxy the size of our Milky Way. However, most galaxies are not the site of such a violent outburst. Quasars are thought to gain power through the accretion of matter around supermassive black holes in the nuclei of these galaxies. No other mechanism seems capable of explaining the immense energies released and their rapid variability. But some phenomena remain unexplained to this day. For example, some relatively quiet galaxies seem to suddenly become quasars in just a few months. The remarkable luminosity of quasars is used as a tool for probing intergalactic space, right up to the limits of the observable universe. Before reaching our telescopes, the photons emitted by quasars may encounter tenuous clouds of intergalactic gas on their billion light-year journey. Quasar absorption systems provide additional structural information to that provided by the distribution of galaxies. The growing number of known quasars, with their absorption spectra, enables more detailed statistical studies of the distribution and properties of intergalactic gas clouds and their relationship with dark matter and existing or forming galaxies. Absorption systems can be used to probe precise moments distributed throughout the history of the universe, but also to address essential issues in cosmology and even physics. The first quasars were seen as early as the late 1950s, and today there are over 100,000. Quasar 3C273 lies at an astronomical distance of 2.44 billion light-years, 1,000 times further away than the Andromeda Galaxy. It is located in the constellation Virgo. According to Hubble's law, and given its distance, this quasar is moving away at almost 50,000 kilometers per second, or 31,000 miles per second. The black hole at its center needs the equivalent of several hundred times the mass of the Sun per year to feed itself. It discharges some of this matter in the form of an immense jet. When it no longer has enough energy to feed itself, its host galaxy will revert to an ordinary star, and its luminosity will diminish. If there's one object in the universe renowned for its unprecedented violence, it's the quasar 3C186. This double quasar emits waves in all domains of light. It lies in the Lynx constellation, more than 8 billion light-years away. 3C186 lies at the heart of the galaxy, PGC 2817581. It has several special features. Its central light is offset by around 35,000 light-years from the center of the galaxy. This is due to the interaction between 3C186 and the second black hole inside it. The impact of these two supermassive black holes disrupts the galaxy, breaking it up and scattering its stars. The interaction between the two black holes is thought to have taken place 5 million years ago. Astronomers estimate that 3C186 will leave the galaxy in around 20 million years. The result will be two supermassive black holes merging to form a black hole with a mass equivalent to 1 billion solar masses. The Earth has been hit by numerous asteroids. These collisions have played a major role in the history of its formation and evolution. Some 9 billion years have passed since the Big Bang. The local supercluster contains over 10,000 individuals. On its periphery, the local group is made up of some 50 galaxies, including the Milky Way, one of the largest. The Milky Way has a thin disk of stars and gas. This highly diluted gas concentrates in a few places, in much denser spirals. These interstellar clouds are opaque with molecules and grains of dust. One of them wanders proudly 27 light-years from the center of the Milky Way. Then, a fragment of this nebula collapses in on itself. The contraction transforms the globule into a protostar, and its energy into radiation. At its heart, the temperature rises so high that thermonuclear reactions cause hydrogen to fuse. A star is born, but not just any star, our Sun. Before its final contraction, the protostar is surrounded by a disk of gas and dust, which then divides into countless smaller bodies. Some agglomerate into larger structures. Matter spinning too fast to join the Sun in formation takes the form of a disk made up of gas, dust grains, and tiny aggregates of solid matter. The grains gradually stick together until they agglomerate into blocks. Under the effect of gravity, bodies over 1 kilometer in length are formed. The largest of these absorb everything within their sphere of influence. Planetary embryos are born. Their mass increases with distance from the Sun. Below the ice line, the environment is gradually emptied of gas, and the planetary embryos see their orbits lengthen to the point where they can cross each other. Violent collisions ensued, leaving only 4 of the planets, including Earth, intact. Barely scratched out of the ground, the Earth is already experiencing an eventful life. Our planet has cleaned up its orbital zone. The only exception is the 2 Lagrange points, L4 and L5, in the Earth-Sun system, which provide shelter for planetesimals attracted to the Earth during its formation. Point L4, for example, shelters a planetary embryo that continued to develop until it reached the size of today's Mars. Its name is Theia. Having reached too great a mass, Theia became unstable and escaped from its L4 equilibrium point. It then orbits the Sun until it collides with the Earth. Theia is totally shredded. Its pieces scatter all around. Its core, mainly iron, is buried in the heart of the Earth. 24 hours after impact, our future planet is surrounded by a disk of light rock from the 2 planetary mantles that collided. After a few years, these rocks agglomerate to form a new celestial object 20,000 kilometers or 12,500 miles from the Earth, which gradually moves away to become its satellite, the Moon. At first glance, this cosmic collision seems no more exceptional than any other. And yet, by giving the Earth such a large satellite capable of stabilizing its axis of rotation, this collision is paradoxically an essential event in the future evolution of life. The Moon plays a very important role in the existence of life on Earth. It exerts a major influence on the weather, the migrations of certain animals, the Earth's magnetic field, and in many other areas. It is also responsible for the 24-hour day. The Earth's tilt is kept stable by the Moon's gravity. If it weren't for the Moon, our planet would move up and down during its rotation. And if such wild movements were to take place, wind and clouds would move faster, and weather conditions would be extremely harsh and much less conducive to life. The phenomenon of the 4 seasons is also due to these changes in the Earth's rotation and axis. Without the Moon, the Earth would rotate on its axis in 8 hours instead of 24. The Moon's gravity slows down the Earth's movement, with enormous repercussions for the evolution of life on Earth. If a day lasted 8 hours, animal species would have had to adapt to rapid temperature changes and would certainly have evolved very differently. During the Moon's first days, solar winds were much more violent. At that time, the Moon was closer to the Earth, and its magnetic field was sufficient to protect its atmosphere and act as a shield against solar winds. If the Earth had no atmosphere, life as we know it today would not be possible. It contains the oxygen we breathe and protects us from ultraviolet rays and cosmic rays. The effect of the Moon's and Sun's gravity on the Earth slightly deforms the planet from front to back. This is what we call tidal forces, which cause ocean tides. Tides probably propelled the first forms of marine life onto land. Tides may also have influenced the Earth's plate tectonics. It is thanks to seismic activity that the planet's surface was able to cool and become habitable. "4 billion years ago, large-scale meteoric and cometary impacts hit the terrestrial planets. It was during the Apollo 15, Apollo 16, and Apollo 17 missions that this theoretical period in the history of the solar system was brought forward. The landing sites for these missions were established close to the great impact basins of the Sea of Rain, the Sea of Nectar, and the Sea of Serenity. Lunar rock samples were collected, and analysis on Earth revealed that their age ranged from 3.8 to 4.1 billion years, a relatively short period. These data were compared with the dating of other lunar meteorites recovered on Earth. Due to erosion, impact marks of ancient origin are very rare on our planet. Although this has long been interpreted as proof that the Earth's surface remained liquid for a long time, it would appear that in reality, the solidification time was much faster, and that the youth of the Earth's crust is due to the theory of the late Great Bombardment. At the start of the solar system's formation, the 4 giant planets were much closer together than they are today. Uranus is the furthest from the Sun, and lies close to the inner edge of a planetesimal-rich disk. Barely 600 million years after the formation of the solar system, the gas giant planets began to migrate due to gravitational interactions with the famous small objects that remain at the inner edge of the disk. Saturn, Neptune, and Uranus are moving strongly inwards, and Jupiter more moderately. Jupiter's rotation period around the Sun is half that of Saturn. This movement completely destabilized the solar system, and collisions between small bodies and the terrestrial planets increased. It was the beginning of chaos. Saturn was pushed back into its final orbit by Jupiter, and collided with Neptune and Uranus. The latter two are expelled into much more elongated orbits. They plunge into the planetesimal-filled disk, ejecting thousands of planetesimals far from their original orbits. For the most part, these small bodies fly outside the solar system, giving rise to the Kuiper Belt, among others. But some of them head inland. The 4 terrestrial planets, as well as the Moon, are the victims of numerous brutal impacts. The Earth is said to have been hit by 22,000 giant meteorites. Some asteroids were larger in diameter than France. The oceans that covered the Earth's surface were partially vaporized. Mercury, the Moon, and Mars bear the scars of this massive bombardment. On Mars, the Hellas Planitia impact basin has been linked to the Great Late Bombardment by analysis of lunar samples. The basin measures around 2,200 kilometers, or 1,400 miles in diameter, and 9,500 meters, or 31,000 feet in depth. It is the largest impact structure on Mars visible from Earth. The basin appears as a bright area due to the high albedo of the dust constantly stirred up by the winds. The Hellas Planitia basin is surrounded by relief created by the impact. For over 1,000 kilometers, the terrain was raised. To the west, the edge of the basin is marked by a mountain range. In places, it reaches an altitude of 2,000 meters or 6,500 feet. To the east, the edge is marked by valleys, representing the beds of large rivers that have now dried up. Water was abundant in the impact basin. On the planet Mercury, The Caloris Basin is the most massive meteor crater known to date. It is located at one of the planet's two hot poles. Measuring around 1,550 kilometers, or 960 miles in diameter, it was formed by the fall of an asteroid with a diameter of around 150 kilometers, or 93 miles. The basin is surrounded by mountains that rise to almost 2 kilometers, or 1 mile in height. Its floor is filled with cooled lava, reminiscent of lunar pools. For some 1,000 kilometers, or 620 miles, the material ejected by the impact forms rings surrounding the basin. The impact that formed the Caloris Basin is thought to have triggered volcanic activity on Mercury. The impact is also thought to have released heavy elements such as sodium and potassium from the planet's mantle. Being around 130 kilometers, or 80 miles deep, elements could have been brought up from the mantle during readjustment movements. On the Moon, the Mer Orientale and the Mer des Pluies are basins that would also have been dug during the Great Bombardment. The Mer Orientale is a lunar sea formed by the impact of a meteorite, which raised the mountains bordering the crater. It is one of the Moon's most impressive structures, with a diameter of around 900 kilometers, or 560 miles. Two mountain ranges encircle the Mer Orientale: the Montes Rook, measuring 700 kilometers, or 430 miles in diameter, and the Montes Cordillera, measuring 900. The Sea of Rains is a sea found on the visible side of the Moon, formed when liquid lava filled a giant pre-existing impact crater, called the Basin of Rains. The latter is surrounded by 3 mountain rings, each composed of several mountain ranges. For some 800 kilometers, or 500 miles, an area is covered by ejecta, forming a region of numerous reliefs. Asteroid impacts are common phenomena in the solar system. 160 million years ago, a collision between two large objects in the asteroid belt produced numerous fragments, known as the Baptistina family. The first body is located on the inner edge of the asteroid belt, just over 2 astronomical units from the Sun. Despite the fact that its growth is limited by the disruptive presence of Jupiter, it boasts a diameter of 170 kilometers, or 100 miles, a very respectable size. It is one of the largest asteroids in the main belt. The second body involved in the collision is another asteroid, 60 kilometers, or 37 miles in diameter. Its orbit is similar to that of the first asteroid. One day the two collide. The impact occurs at a speed of 3 kilometers per second, or 1.8 miles per second. It was so violent that the two asteroids were reduced to a dust of debris, which aggregated again to form a family of objects with similar orbital characteristics. This is the Baptistina family. This asteroid family comprises some 2,500 known members. Many years ago, we thought that some of them were responsible for remarkable cosmic collisions, such as the one that caused Tycho's crater on the Moon, or a direct collision with the Earth 66 million years ago. However, data from the Wide Field Infrared Survey Explorer in 2011 challenged this hypothesis, suggesting that the Baptistina family had in fact formed much more recently than previously thought, as recently as 80 million years ago. Consequently, the origin of the impactor that caused the extinction of the non-avian dinosaurs remains an unsolved mystery. Further study and exploration of the asteroid belt may one day unravel this mystery and help us understand the forces at work that triggered these impacts. Asteroids can undergo an effect that affects their rotation on themselves in the presence of radiation. When the object's face is illuminated by the radiation source, it receives energy. After half a revolution, this same face then goes into shadow, radiating outwards the energy it has previously received. The result is a very slight thrust exerted on the object, depending on its shape and surface condition. This is known as the Yarkovsky effect, named after the Russian engineer who discovered the phenomenon. Many individuals are then disrupted by Jupiter and the other planets. They find themselves injected into orbits that lead them to cross those of the Earth and Moon. 108 million years ago, an asteroid measuring 10 kilometers or 6 miles in diameter swung low over the Moon's western horizon and collided with it. The impact creates a huge impact crater called Tycho. This sends thin cracks across the Moon's southern hemisphere, extending to over 1,000 kilometers or 620 miles in all directions. The crater is located in the southern lunar mountains. It has well-defined contours, and its interior is characterized by a high albedo. The crater's diameter is 82 kilometers or 50 miles, and its rim rises to 4.7 kilometers or 3 miles above floor level. At that time, from Earth, it was the dinosaurs who witnessed this cosmic collision. Little do they know that they will be the next victims of these cosmic events. The Chicxulub crater is the most famous asteroid impact on Earth. It occurred around 66 million years ago in Mexico's Yucatan Peninsula and is associated with one of the world's largest mass extinctions. The impacting asteroid measures around 10 kilometers in diameter. On contact with the Earth, it formed a crater 180 kilometers, 112 miles in diameter. This suggests an explosion power several billion times that of the Hiroshima bomb. The crater basin is covered by about 1,000 meters, or 3,300 feet of limestone. It extends under the mainland and the Gulf of Mexico. Scientists are trying to explain what really happened during the impact that caused the demise of those who reigned supreme at the time, the dinosaurs. At the time, these gigantic, majestic animals had dominated the planet's animal ecosystem for 165 million years. They are the most imposing creatures the Earth has ever sheltered. Dinosaurs are very diverse and are found all over the planet. An asteroid in a region between the orbits of Mars and Jupiter is projected at several kilometers per second. It heads straight for the Earth until impact, forming a huge crater. The energy released was so intense that the rock of the Earth's crust liquefied. In less than a second, all the water within a 60-kilometer radius of the impact turns to steam. Animals in the vicinity are instantly killed. A few seconds after impact, the shock wave releases an unbearable heat that crosses the ocean. Everything in its path evaporates or melts. It would take just a few years for life to reappear in the impact crater, but over 30,000 years for a thriving ecosystem to develop. Scientific research has revealed the presence of burrows dug by shrimps and worms, as well as microfossils of plankton and algae. This suggests that the crater became habitable shortly after impact, even though the mass extinction was not yet over. Evidence of this impact was confirmed just before the 1980s. A thin black layer of clay just a few millimeters thick was revealed in some of the geological layers between the Cretaceous and Tertiary strata. This geological boundary contains abnormal levels of iridium. Although rare on Earth, iridium is found in abundance in certain meteorites. Scientists sometimes find minute quantities of iridium in terrestrial sedimentary rocks due to the fine, micrometeorite showers that are frequent on the planet. But analysis of this Cretaceous-Tertiary layer reveals far more. This is why it has been suggested that the planet must have suffered the fall of a huge meteorite. At the time, the crater could not be found. In 1981, two geophysicists employed by the Mexican oil company Petróleos Mexicanos investigated the Yucatan and discovered this unusual geological structure. The fall of this meteorite marked the end of the Cretaceous period and was responsible for a climatic upheaval that led to the extinction of non-avian dinosaurs and a large proportion of the animal and plant species at the time, both on land and in the seas. Without this event, Earth's history would be totally different, and we certainly wouldn't be here to talk about it. The Vredefort Dome is the largest known impact crater on Earth. It is located in South Africa, in the territory of the Free State Province. In 2005, Vredefort Dome was inscribed on UNESCO's World Heritage List for its scientific and scenic interest. The town of Vredefort was built inside the impact crater. The asteroid's impact dates back 2 billion years. Until recently, it was the oldest known impact crater on Earth, until the discovery of Maniitsoq Crater in Greenland, estimated to be 3 billion years old. The asteroid's diameter has been estimated at 15 kilometers or 9 miles. It left a crater with a diameter of around 300 kilometers or 186 miles. Vredefort is one of the few craters to feature multiple terrestrial rings, a phenomenon often destroyed by erosion and plate tectonics. The dome is only the central part of the astrobleem, which actually extends over 360 kilometers or 224 miles in length, from Johannesburg to Welcome in the Free State. South Africa's geological stability has ensured the crater's continued existence. It is one of the only craters to have been crossed by a river, the Vaal, for almost 280 million years. The asteroid's impact would have really damaged the planet, causing fires all over the world. The enormous quantity of dust thrown into the atmosphere would have altered the climate for years. Located in Ontario, Canada, the Sudbury Basin is a crater formed some 1.85 billion years ago. It is the second largest known impact crater on Earth, but also one of the oldest. It is located on the Canadian Shield in the city of Greater Sudbury. The Sudbury Basin is 62 kilometers or 39 miles long, 30 kilometers or 19 miles wide, and 15 kilometers or 9 miles deep. The diameter of the meteorite has been estimated at around 10 kilometers. Some of the rock fragments ejected on impact traveled more than 800 kilometers, or 500 miles, and were scattered over an area of 1.6 million square kilometers. Scientists even suggest that such an impact may have scattered debris around the world, but that it has since been eroded away. The impact that created the Maniitsoq Crater is thought to have occurred around 3 billion years ago. It is the oldest known terrestrial meteorite crater, yet remains totally invisible today due to erosion. By analyzing the nature of the rocks, scientists were able to prove that it was an asteroid impact. The asteroid would have had a diameter of around 30 kilometers or 19 miles and would have hollowed out a crater, originally 600 kilometers or 370 miles in diameter. At the time, only bacteria were beginning to populate the planet, but if such an object hit us today, it would exterminate all forms of life on Earth. Also known today as Meteor Crater, Barringer Crater is located in Arizona, USA, 60 kilometers or 37 miles east of Flagstaff. It is a well-preserved crater, formed by the impact of a small asteroid around 50,000 years ago. At the end of the Pleistocene, an object of peculiar composition hurtled towards the Earth. Made of iron and nickel, it is more likely to be a fragment of a planet core in the process of forming than a small body from the early solar system. As a result, it is much more resistant to the stresses imposed by the Earth's atmosphere than blocks of rock or ice. Once it reaches an altitude of around 14 kilometers or 9 miles, it eventually breaks up under the effect of increasingly dense layers of air. The meteorite splits into two parts, with a block of half its initial mass on one side and smaller fragments surrounding the initial impact over a diameter of 200 meters or 660 feet on the other. The main block, weighing 300,000 tons, hits the Earth at a phenomenal speed at 12 kilometers per second or 7 miles per second. The collision forms a crater over a kilometer in diameter. At the time, this area was grassy savanna occupied by mammoths and sloths. The impact releases energy equivalent to that of a thermonuclear explosion. All life is destroyed within a radius of several kilometers due to the blast and heat generated by the collision. The impact did not cause any noticeable change in the planet's climate. Meteor Crater is bowl-shaped, measuring almost 1,400 meters or 4,500 feet in diameter, and 190 meters or 620 feet deep. Today, it is a popular tourist attraction. Warburton Crater is located in Australia near the town of Ora Banda. Its diameter is around 5 kilometers or 3 miles. The asteroid's impact is thought to have taken place 100 million years ago during the Cretaceous, well before the impact that formed the famous Chicxulub crater. The Warburton crater was discovered in a very flat landscape. Erosion has taken its toll, and there's no sign of a crater on the surface. The impacting asteroid must have been between 100 and 200 meters in size, or between 330 and 660 feet in diameter. The crater is buried under several kilometers of sediment. It is not a single impact crater, but two craters, 200 kilometers or 125 miles wide, forming a structure 400 kilometers or 250 miles in diameter. The two impacts may have occurred simultaneously due to the fragmentation of an asteroid. The Popigaï crater is located in Siberia. It is the fourth largest known terrestrial impact crater, with a diameter of around 100 kilometers. It was formed by a meteorite impact 35.7 million years ago, during the Upper Eocene. It has been designated a geopark by UNESCO as a site with a specific geological heritage. Popigaï is also the world's largest diamond mine. During the Cold War, it was kept secret for decades. Shock waves from the impact would have instantly transformed graphite into diamonds within a radius of 14 kilometers or 9 miles. This mine would contain the equivalent of 10,000 billion carats. Just over 200 million years ago, an asteroid hit the north shore of Quebec in Canada, forming the Manicouagan crater. It is one of the oldest and largest impact craters on the planet. Due to erosion caused by glaciers, it is not easily visible on the Earth's surface. Its concentric structure, around 100 kilometers or 62 miles in diameter, is explained by the shock waves transmitted during the impact. The meteorite responsible measured around 5 kilometers or 3 miles in diameter. Comet Shoemaker-Levy, sometimes abbreviated SL9, is famous in astronomy for being the first to offer direct observation of a collision between two solar system objects outside the Earth. It has been closely observed by astronomers from all over the world. Comet Shoemaker-Levy broke up as it approached the planet Jupiter, colliding with it in July 1994. This collision led to the discovery of new elements about Jupiter and highlighted its key role in reducing the amount of space debris in the solar system. This comet is unusual in that it has been orbiting Jupiter for some time, rather than orbiting the Sun, like all the other comets known at the time. By 1992, it had already passed very close to Jupiter, just over 40,000 kilometers or 25,000 miles from the cloud tops. The 1994 collision was by far the closest and resulted in the comet's fragmentation. Each fragment is designated by a letter, ranging from fragment A to fragment W. The 1994 encounter was eagerly awaited. Astronomers had prepared their terrestrial telescopes, and several space observatories were ready to observe the impact live. On July 16, 1994, at just over 8 p.m., fragment A struck the southern hemisphere of Jupiter at a speed of around 60 kilometers per second, or 37 miles per second. A fireball then formed. A fireball was formed, reaching a temperature of around 24,000 degrees Celsius, or 43,000 degrees Fahrenheit, before dropping rapidly to around 1,500 degrees Celsius, or 2,700 degrees Fahrenheit. After this initial impact, observers see a huge black spot. These were the effects of impact debris. Over the following week, 21 impacts were recorded, the largest of which was produced by fragment G. It took place on July 18th at around 7:30 a.m., creating a giant dark spot over 12,000 kilometers or 7,500 miles wide. On July 22nd, the final fragment, fragment W, struck Jupiter. Direct observation of this collision provided a wealth of information about Jupiter. The planet has since been regarded as a kind of cosmic vacuum cleaner within the solar system. Jupiter's strong gravitational influence attracts numerous small comets and asteroids. Its impact rate is estimated to be between 2,000 and 8,000 times greater than that of our planet. In other words, if it weren't for Jupiter, asteroid impacts on the other planets in the solar system would be far greater. Astronomers have even gone so far as to hypothesize that without Jupiter to intercept potential impacts, collisions leading to mass extinctions, such as the cosmic impact that caused the Chicxulub crater, would be much more frequent, and Earth would certainly not have been able to witness the development of complex life forms. The study of past impacts, their frequency, and the reason why they occur allows us to better understand geological history. Collisions play an essential role in the formation of new galaxies, for example, and help us to understand these complex structures and their gravitational interaction. The study of impacts enables us to retrace the history of bodies and better understand the processes of accretion and planetary differentiation. Gravitational interactions between bodies during collisions can help scientists map the distribution of matter in the universe. Far beyond understanding the universe itself, the study of past cosmic collisions enables us to predict future events. In a much more distant future, around 4 billion years from now, our own Milky Way galaxy is predicted to collide with its nearest neighbor, the Andromeda Galaxy. Scientists now determine that the two galaxies are heading towards each other at more than 100 kilometers per second. Even if the stars, because they are so far apart, pass each other without colliding head-on, the interstellar clouds will interact until they form a blaze of stars that exhaust almost all the available gas. This collision is considered a major encounter and will have a significant impact on the structure and evolution of both galaxies. Current research suggests that they will merge to form a new elliptical galaxy, devoid of interstellar gas. The latter will remain dominant in the local group. The sky as we observe it today is ephemeral, even if the changes in the course of a single human lifetime are infinitesimal. But in a few million years' time, the map will be completely different.